This video will focus on distance between 2 points on the coordinate plane. So let's jump right into an example here. So for example, if I wanted to find the distance between the coordinate 2, 3 and the coordinate 5, 7, well, first off, I think it'd be beneficial for us to draw a picture of what's going on here. So the first thing I'm going to do, I'm going to make a quick axis here. And remember that the x-coordinate comes first, the y-coordinate comes second. Same for the 5 and the 7 over there. So, first thing we're going to do, we're going to plot the point 2, 3. So I'm going to go right 2 and up 3. We'll put a point right there. And then we will do the same thing. We'll go over 5 and up 7, which is all the way up here. Okay, now, if we think about this for a second, what we really want to find is this distance between these 2 points. This is what we really care about. So let's call it something. For now, I'm thinking let's call it D for distance. Okay? So, if we think about this, finding the distance by itself, we don't have a lot of numbers to work with here. However, we can look at the difference between the x and the y coordinates. So this would be a line, this blue dotted line here is parallel to the x-axis. Since we're looking at, okay, how far over did I go? And this is a vertical line, the other one is vertical. We're just looking at the change in y. So if we think about this, this is the point 2, 3, and this is the point 5, 7. If we think about the horizontal change here, well, I'm looking at from 2 to 5. That would be 3. So the size of this side would be 3. And then likewise, if we're looking at the vertical, this guy right here, this distance, we're looking at, okay, how far is the change from 3 to 7? Well, we could take 7 minus 3, and that would be a distance of 4. So let me recreate this triangle over here. What we have, even if it may not look it, is this right triangle right here. And if you remember from the last lesson, we talked about Pythagorean theorem. And remember Pythagorean theorem, a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse, the big side. So if we substitute our values here, we're going to take this, plug it in. So what we'll have is 3 squared plus 4 squared, because those are the legs of my triangle. And then that's going to equal d squared, which at this point, we simplify the left side, we can get those numbers a little easier to work with. It looks like we'll have 9 plus 16 equals d squared. And then once that happens, we can combine the 9 and the 16. 25 equals d squared. And then d will equal the square root of 25, which we know d is 5. So, in answer to our question, the distance from 2, 3 to 5, 7 will be 5 units. So the trick here is to make a right triangle out of our segment where we're looking at the change in x and we're looking at the change in y, and we just have to think to ourselves, okay, how long would that distance be? Now, if we throw in negative numbers, that'll make things a little bit different, but same concept still applies.